Yesterday we discussed about the calculation script. Okay, so how we aggregate the data and how we calculate the data using the scripts. Okay, so
Mhm.
today we see a few more functions which will be used in the calculation script. Okay, so there are three types of space operators. One is mathematical operators like we can use mathematical functions like sum if you want to find the sum of some values, or you want to use some find absolute values, then we use the mathematical functions. And if you want to use some conditional operators like if else or and or not, this then we use the conditional operator. And also we use the cross dimensional operators. Okay, so these are the few space operatives we'll be using it in the calculation script. And and also we can assign the constant value to any member. Uh, and also we can assign some non-constant values. Okay? Just we can add the constant value with some other member and assign that value to the specific member. And let's talk about the conditional test. Okay, so using if and else statement, we can do the conditional test. Okay, so in the conditional test, we have to pass some parameter like this is one of the function. It will return true or false if that based on the member we pass to the child member. Okay, so I have one hierarchy. Okay, I have one hierarchy. Product A. Under product A, I have product 1, 2, 3. Okay, so I want to perform some conditional test. Based on the test, I go to calculate something, calculate sales based on the product one. Like that, I go to calculate something. Okay, so I have to write script like that. If is child of product A. Okay, and also here I am making some fix. I descended of product A. Okay, here I make some calculation. Sales equal to product one multiplied by 100 something, and end if end fix. Okay, so first I'm using descendant function. Okay, which will return all the members which is created under product A. Okay, so we are to it will make some loop. It will bring all the data block related to the product A and perform the calculation. So next, it performs the conditional check. Okay, for example, it will take that member product one. Okay, the first data block, and it's checking whether it's a child of product A. Okay, and it returns true because the product one is created under the product A and it's a child of product A. So it's true, and the conditional test is passed. Okay, so next it's execute that this equation sales equal to product one multiplied by 100. Okay, so this is how the conditional test is performed. Similarly, we can use his descendant, his sibling. Okay, here I have given some example. If that the specific member is descendant of his, then it perform the calculation. Okay, so we can use the else, if, else if, and else statements. Okay, and these are the few mathematical operations. Okay, there are many mathematical functions you can use it. Here I have given a few examples. Absolute. If you want to find out the minimum, you can use at the rate of min. And we already discussed about variance reporting. Okay, it's a difference between the two members, maybe the actual or minus budget, like that. Okay, for example, I'm trying to find out that difference between actual and budget data. So here it may return negative numbers. If it is returns a negative number, that's the absolute function will change the sign of that data. It will return only the positive numbers. Okay. So in that case, we'll be using the absolute function. And if we want to find out the minimum values for the few specific range, then we can use the minimum function. For example, for January, February, and March month, I got sales of uh, some dollars, 678, 45, 675. Okay. So I need to find out the minimum value of that quarter one. If you if you use that function, it will return 645 because that minimum value is 645 here. Okay, so I have to give that period range in that minimum function and execute it in the calculator. Okay, so these are few examples how we use a mathematical operation in the calculator scripts. And these are the few logical operators. Okay, we already discussed about if, else, and else if. Okay, and if you want to check based on the number is greater than or less than with a specific number, we can use these logical operators. And also we can use and or not. Okay. So these are the operators we'll be using the calculus scripts. And for example, if we want to use some relationship functions, we can use at the top generation, xref, xwrite. Okay. For example, the generation of year returns 1 because it's the top level member and that the generation value is 1. And the next hierarchy is quarter 3 and it has a generation value of 2. So if you use the generation function, it will return the value of the generation. Okay. Like that, we can use xref, xwrite. If you want to get the data value from another database, okay, just we can use xref or xwrite. Mostly we'll be using it in the partitions. Okay, in the partitions, we have the source database and the target database. Okay, so if you want to calculate that or fetch the data from another database, we can use the xref or the xwrite functions. Okay, maybe we can discuss about the partitions later. And these are the range functions. For example, if you want to get the value of the previous or the prior member, we can use that prior function. And if you want to get that sum of the specified member, okay, if there is some range, we can find out the sum for that for those members. For example, here I am trying to find out that sum for the New York and the range between Jan to June. Okay, so for the Jan to June, I have these much data. Okay, so if I apply that sum range function, it will sum all that data for the given periods and will provide the results. And for example, if I use the prior functions, I use prior of product one. Okay, so this function will return product A. So the product is a prior member of product one. And these sort of using these functions, we can get that member list. For example, if I use it children at the rate of children function, for example, I'm using that function on that parent member product A. Okay, so it will return all that children from the product A. It will return product 1, 2, 3. Okay, and if I use that function on the product B, it will return product 4. Okay, and if I use I children, okay, I means inclusive. So this function will return product A and also it will return children of product A, product 1, 3, product 1, 2, 3. Okay, it will return 4 members. It will include the parent member as well. This will exclude the product A and it will return the children of the product A. And another function is descendant. This is also similar to children, but it will return all the descendant of product A. Okay, for example, I have one more hierarchy here. Here I have market something. Okay, under market I have few more members. So under the market I have product 2 and 3. Okay, if I use a descendant, it will return all the hierarchy, excluding the product A. It will return product 1 and the market market. Under the market, it has two children, right? So it will return product 2 and 3. Okay. So it will return all the descendant of product A. And if you specify I descendant, it will include the product A member. Okay, it will include the parent and its descendant. Okay. So similarly, we go on many functions we can use that. Okay, so these are the few examples for that airspace functions, which will be used in the calculus script. Okay, maybe you can try with a few functions and let me know if you have any questions. There are around 100 functions, I guess. Okay, so maybe you can go through that. Because these are the very important formulas. Okay, we are using it in all that application like planning and budgeting, FCCS. We are using a lot of application. These are the basic functions. Okay. Okay. Uh, Next talk about ASO and BSO cubes. Okay. I already told you there are two types of space applications. One is aggregate storage and another one is black storage. BSO cubes, black storage option. Okay. In that aggregate storage, we'll be having the tens and the sparses concept. Okay, using that. Sorry, in the block storage. So in the block storage, the data is stored as the data blocks. It will create the data block based on that sparse and dense combination. Okay, so for this combination, it will create the data block and it is stored as the page file. Okay. But in aggregate storage, we don't have the tens and the spots concept. Okay, all the members considered as spots dimensions. And also, it won't create any data block. Okay, if you want to store the data in ASO, it will store as the data slide. Okay, it will be stored the data in the buffer. It allocates some buffer size. In the buffer, it will store the data. We call it as data slides. It will create multiple data slides for each node. Okay. So later we can merge those data slides, and if there is any zero records, we can remove that. Okay. So this is the difference between ASO and BSO database. The major difference are the ASO doesn't have any dense and sparse functionality, and BSO it has that dense and sparse dimension type. Okay, and also in aggregate, if you in ASO the data is stored in the buffer. Okay, in BSO the data is stored as the data blocks. It will create the data blocks. Okay, so these are the major difference between ASO and BSO, and also in ASO, we cannot use any calculations. Like yeah, earlier, we were discussing about the calculation functions, right? Like calculus scripts and functions. Okay, we cannot use those calculation in that ASO cube. Okay, and if you want to perform any complex logic, or if you want to write some allocations logic, then uh, you cannot do it in the ASO. Okay, so you have to decide which cubes you want to design based on the business requirement. If their main focus is on the calculation side, or they want to calculate something, then you can you can go for the BSO. Okay. If their business main focus is on the reporting side, then you have to choose ASO. Because in the ASO, you can just do the reporting. Okay. You cannot do any calculations, or you cannot perform any uh, and also you cannot create any member formula. Yesterday we talked about the member formula, right? In the outline, we can create some member formulas and perform the calculation. But in ASO, it's not possible. It's possible, but for that we have to write some MDX scripts. Okay, that's very complicated. Okay, and the another advantage of ASO is, for example, here for the product I go only the few member product 1, 2, 3. Okay, so here I am using very less number of members in the for the product A. Okay, but consider you go more than 100 product, or more than 1,000 product. Okay, for the specific region. then if you're using the BSO, it's going to impact your performance. Okay, because you go to calculate all the product, all it has to aggregate all the product to one specific parent. Okay, surely it will impact the performance of that aggregation or the calculation or something. Okay, so the best way to design the application is ASO. In ASO, you can create any number of members. Maybe you can have 1,000 members or the 10,000 members. Okay, uh, it won't impact the data retrieval because the data is stored only at the level 0 member. It won't be store the data at the parent level. Okay, but and also in if you want to aggregate the data, you don't need to write any calculation script or yesterday we were talking about that calc dim calc aggregation something, right? You don't need to run any script. Okay, so during the data retrieval, it automatically aggregate the data to the parent member and you can report the data. Okay, so once that reporting is done, it automatically arrays the data at the top level. Okay, so
Okay.
always the data will be stored in the level 0 member, and also you can enter the data at the level 0 member only. Okay, so mostly if there are large volume of members, okay, I have many customers, I have many branches. Okay, in that case we have to use the ASOQ for the reporting. Mostly it is used for the reporting purpose, not for the calculation purpose.
Okay.
Okay, for example, I give you another example. I have one planning application. Okay, here in the planning application I am doing all that I'm loading actual data. Based on the actual data, I'm doing budgeting. Okay, I'll do
Mhm.
budgeting and will do forecasting. Okay. Once I completed with budgeting and forecasting, I will push the data to Essbase. Okay, so the data will be stored in the Essbase applications. All this data will be stored in Essbase application. Okay, so in Essbase, I create one PSO cube and ASO cubes. So all the data will be stored in PSO cube. Whatever I enter in the planning cube, right? So those
Mhm.
data will be stored in the BSO. Okay. Now I want to do the reporting out of that Essbase applications. So the best way to take the report is I can use the ASO cube. From the ASO cube, I can generate the report because the performance of the ASO cube is very good. Okay, so here I will be doing the report. Okay, so for the ASO cube, I will get the data from the BSO cube. Maybe I will create some partitions, or I will do some data push using that smart push or some logic. I will bring the data from BSO cube to ASO cube. Here I will transfer the data to ASO. Okay. So from the ASO cube, I will do the reporting. Okay.
Okay.
So this is the
Okay.
purpose of the ASO cube. We don't directly connect into BSO and take the report. Okay. So this is one of the advantage of using the ASO cube. Okay. Mostly it's used for the reporting purpose. So the things. So here this is an example for the ASO cube. If you look at that cube, right, there are lots of dimensions. Okay. In BSO, we cannot have many dimensions. We can have it, but it will impact the performance because it will create many data blocks and it will create many index. Okay. So it's only used for aggregate intensive cubes. Okay. And handle larger number of dimensions and members. And data is aggregated on the fly. Okay, that means while you are doing the retrieval, that will be aggregated, and you can create some views in Oracle database. We create some views, right?
Right.
So similarly, we can create some views in the ASO cube. Okay, and mostly this is used for the reporting purpose, and BSO is used for analysis or the calculations purpose. So and also in time dimension, we were using that YTD, MTD, the dynamic time series, right? So those features are not available in ASO. And also we can create only one database in ASO. Remember in BSO, we were able to create a main database, and also we can have that currency database. Okay, and also we can create multiple base database in BSO. Okay, but in ASO we cannot have that multiple database. We can have only one main database, and we cannot have any calculation script and formulas. But we can write to formulas that can be achieved using the MTX query. Okay, we can write some scripts similar to that calculus script, like using the MTX language, we'll be creating some formulas. Okay, and it support only one type of a partition. It's called a transparent partition. So these are the difference between ASO and BSO queue. So next we talk about partitions. So we have three types of partition. One is replicated, transparent, and linked. Okay. For example, I have data. Okay. I have this intersection. Okay. I have here we have three regions: EU, India, USA. Okay. And I have three business users from Europe region, India, and USA. Okay. So the business users from EU wants to see the data from the Europe entity. They don't want to see other regions. Okay, just they want to see only the Europe region. The data belongs to Europe region. Okay, so and also that the business users from India want to see uh, their India entity. Okay, okay. So we want to restrict the business user. Like we have to create multiple view. Okay, uh, like we want to restrict the business user to see the specific data. Okay, so for that we will be using the partitions. For example, there are two ways. The one is just I can create filter, and I can provision the user based on that region. I can give access to the specific entity. Okay, so the EU business users can see only the EU data, and the India business users can see only the Indian in the sales from the India entity. Okay, so one option is to create a filter, or just I can create user security using the groups or roles. Okay, so that may not be the efficient way. So the another way is I can create the partition. I will create another Essbase applications. Okay, so this one acts like a source database. Okay, I will create another Essbase application or that database. This will be the target application, target database. Okay, so now first I have designed two database. One is source database and another one is target database. And once I got all that details like source and the target database details, I will perform the mapping. Okay, so just I will create the mapping between source and target using that data mapping. Okay, only I will create a mapping for the specific point of view. For example, I will include sales here, product 1, 2, 3, and I will include only the EU entity and FY21 January actual. Okay, so based on the data mapping, the data will be pushed to that target database. Okay, so when the user try to access the target database, they will be seeing only the EU data. They cannot see the other entities like India or USA. Okay, similarly, I will create a multiple target database based on that requirement. Okay, so and also user can retrieve the data from that target database, and also they can input the data. like they can update that data for the EU region and the target application, and uh, they can do that data push to the source database. Okay, so that's also possible in that partition. Okay, so there are three types of partition. Based on the requirement, we can create it. The first one is replicated. Yes, in a replicated means the whole the 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 part of the data is will be pushed to that target database. Okay, just we will be executing a job to perform the database. So all the data will be copied to the target application. Okay, so this is called replicated partitions. So now that the EU user can see connect to the target database, and they can retrieve the data for the EU entity. Okay, and also, but the problem is they cannot update any data in that replicated partition. Just they can retrieve the data and they can do some analysis in the target database. Okay, so but if they want to update something or they want to see that latest data, again they go to refresh the data load. Okay, again I will perform the database and will bring the data from the source database to the target database. This is how the replicated partition is worked. Okay, so the another partition is a transparent partition. So in the transparent partition, we don't copy the data. Here in the replicated partition, just we copy the data, but in the transparent partition, just we will connection between the source database and the target database. Okay. So whenever the user try to access the target database, it will make the connection to the source database and it will fetch the data. Okay. Okay. So that whatever the data is available in the source, that will be reflected in the target database. Okay, so it will have the latest data. You don't need to refresh it every time. If it is replicated partition, you have to refresh it to see the latest data. Okay, and uh, and also in a replicated partition, it will occupy more space because just we are making the another copy of the data. Okay, but in the transparent partition, we don't any make copy, but just we are making a link between target and database. Okay, so the target database acts like a local database. Okay, so there is a difference between replicate partition and transparent partitions. Similarly, we can create multiple target database. Okay, there will be one data source, and using the one data source, we can create multiple target database. And also in transparent partition, we can get the data from multiple source database. Okay, so here we got the one database. So using the one database, we have created multiple data targets. Okay. So if you want to create that partition, we should have that login and password of that Essbase server. And also we need to provide the mapping. Okay, if you mapping between source and target database. So here I have provided some to create a partition. Okay, so if you expand the Essbase application, there are options to create a partition. Just right click on the partition and create new partitions. Next, we go to provide the type, whether it is replicated, linked, or transparent partition. Okay. Next, we go to provide the connection details. This is for the data source and this is for the data target. Okay. And also we can do it through the Maxwell script. Okay. Okay. Either you can do it in the front end, or if you want to automate something, or you can do it through some command prompt, you can use the Maxwell script. Okay, so this is a Maxwell script used to create data partitioning. So here I'll be providing the connection details, and next I go to create the mapping. Okay, first I go to provide the areas, and later I will provide the mapping. Here I'm just selecting what are the dimensions and member used in the partisans, and after that I will be providing the mapping. Okay, like what are the entity used and what are the year and product used in that partisans. Okay, just I go to provide the mapping between source and target applications. Okay, so that screenshot is missing. So once we provided all the details, just we can validate it and create that partisans. Okay, so this is for transparent and replicated partition, and also we can follow the same procedure for the linked partisans. Okay, but the linked partition is different from replicated and transparent partisans. Here in transparent and replicated partition, just we create a multiple database. Okay, multiple database, and we bring the data, that slice of the portion of the data to the target database. Okay, but in the linked partisans, we the procedure is same, but the data cells are linked between source and target database. Okay, we here we create that mapping between data cell. For example, here the product one has $100. Okay, and also I will make the same. Just I will create that reference here. Just I will create a link between uh, product one from the target database and product one from the source database. Just I will create the link between two data cell. Okay, so when I try to access the data cell on that product one, it will make the pointer to data uh, product one from the source database. It will make the link to that source database. Okay, actually the data is not stored in the target database, but whenever you are trying to refer the data cell in the target database, right, it will create a connection to the source database and it will provide that data to target database. Okay, just it will make that connection. It will make the reference. Okay, so we use the linked partitions to get different dimensionality. So here we are mapping the two data cells to create the linked partisans. Okay. For
Okay.
example, in data, the data target, here it has the corporate sales, and in the data source we go to the ES database. Okay, that it has the same data, but they want to use a different functionality, different dimensionality to generate the report. Okay, so for the purpose they will be using the linked partition. Mostly in our reporting application, we never used linked partition. Okay. Mostly we'll be using a replicated partition or the transparent partition. If you are using the planning applications and space application, we'll be using the replicated partition. Every day we'll be reference the data to the target database to get the latest data and we'll do the reporting. Okay. So,
Okay.
okay. So we can view the data in different contexts and you can navigate between two database containing many dimensions. So that is the advantage of linked partisans. And this is a Maxwell script used to create that partisans. Okay. So first we have to log in into that Essbase server using the admin username and password. Okay. And just here to write the Maxwell script, create or replace transparent partisans. You have to give that name. And here we provide that area. Okay. Area means that dimension details. What are the dimensions involved in the partition? Okay. And here we use that target application details. So we have given the target application details and the database details, and also we have provided username password for that application. It may be in the same server or it will be maybe in the different server, Essbase server. Okay, we can have multiple server or multiple Essbase applications. Okay, so based on that, just we have to create the partisans, and here we provide the mapping, whether it's globally mapped or just we go to specify that mapping here. Okay, so if you execute this Maxwell script, it will create that partition. Okay, so this is from that here we have created transfer for partition. We have multiple database. From the multiple database, we get the data to the target applications. Okay, So this is the advantage of transparent partition. From the multiple database, we get the data to one single database. Okay. So here we can see that partition type supported by that data storage. Like we got two types of data storage, like block storage and ASO cubes. Okay. So replicate if the both target and source are block storage, then we can implement all these three types of partitions: replicated, transparent, and linked. Okay. And also, if both the data types, the target and the source application or aggregate over the block storage, we can have it support all these three partitions. Okay. For example, the target application is ASO. That's our I already we saw that scenario, right? In the planning, we can have the source as a block storage and the reporting cube as a aggregate storage. Okay. In that scenario, we can use all these three partition type. Okay, it support all these types. Okay, if that target is plug storage BSO and the source is ASO, it won't support partition. It support only transparent and linked. Okay, this is same case if the both source and target is ASO key, it does not support replicate partisans. Okay, it support only transparent and linked partisans. Okay. So, we want to consider this scenario before we design that space applications. Okay. While creating planning application, also we go to provide whether it's the ASO or the PSO space applications. Okay. So we go to be consider this scenario, and also there is a chance to overlap the data. Okay. For example, in we are getting the data from two data source. Okay, and both data source has the same members. If we get the data from the same member, we will be getting the data will be overlap. I think mostly it will happen on that transparent particles. It happens in the linked particles. Okay, but it's if you are mapping that if you are getting the same data from the different data source in a replicated or transparent partition, it will generate the error. Okay, it's not supported. But in the linked partition, yeah, the data can be overlapped. Yeah, that's it about partisans.